Hello students, today's class we are going to see the propagation of light through optical fiber cables. First of all, let us understand how light enters into a medium and its velocity, how it changes. Then we will understand about the basic principle behind the propagation of light through the optical fiber cables. Now you can see when a light enters into the medium, its velocity is affected, and when it travels from rarer medium to denser medium, for example, the light rays velocity gets reduced due to the density of the medium. Now the direction of the light gets changed and the light ray bend towards the normal. Similarly, when it gets out of the denser medium to rarer medium, the speed of the light ray increases. As a result, it bends away from the normal. Now let's see what is critical angle and how to understand the total internal reflection, which is the basic principle behind the propagation of light through optical fiber cables. Now let's take the ray passes from denser medium to rarer medium. This is the normal and this is the light ray enters into a denser medium. From denser medium, the light ray is moving into a rarer medium, like let's understand from glass to air. So air is the rarer medium. Now the light ray bend away from the normal due to the change in velocity. Now this angle is taken as the angle of incidence in the denser medium, and this is angle of refraction in the air, that is the rarer medium. What happens if the angle of incidence is slightly increased in the denser medium? It is, for example, if this is 30, now you can take it as 35. Now what happens with the refracted ray, and what will be the change in angle R? That's the refracted angle in the rarer medium. You will understand it is going to increase. That is, angle of refraction in the rarer medium gets changed and it is increased. Now if you keep on increasing the angle of incidence in the denser medium, now you will get a point where at a particular angle of incidence for which angle of refraction in the rarer medium, that is in the air, it is going to be exactly 90 degree. So you will understand the ray just glimpses on the interface of both the medium. That is, when it's trying to pass from glass to air, the angle of refraction becomes 90 degree for a particular angle of incidence, and that angle of incidence can be called as critical angle. Now, for the case of total internal reflection, we need to understand from this point that where the angle of incidence in the denser medium is equivalent to critical. Now, you can imagine for the same pair of media, if I increase the angle of incidence in the denser medium slightly greater than the critical angle. Now what happens with the ray? And you have to understand there is going to be always partially reflected ray in all the diagram. In all the cases you will understand there is a refracted ray apart from which there is going to be a partially reflected ray, which is also to be understood. Now in this case, where the angle of incidence is greater than critical, the ray is internally reflected the two totally, in the sense there is no process of refraction. All the incident light is exactly internally reflected and it goes with the same angle whatever it is, as the incident angle. For example, if the incident angle is 42 degree, this also goes as 42 degree. And this process for which the incident rays gets totally internally reflected It is called as the total internal reflection. And let's see what are the conditions for this. Of course, first condition is going to be the ray has to pass from denser medium to rarer medium, right? Number two, of course, the angle of incidence in the denser medium should be greater than critical. So if these two conditions are met, of course the light ray which enters into an interface of denser and rarer medium, it is totally internally reflected. Of course, this is the basic principle which governs the light, or you can understand how the light propagates through the optical fiber due to this basic principle. Now we will understand next part of the class as acceptance angle and numerical aperture.